But I think maybe you have seen this picture before here in the program, yeah? And it says here like, with 1 hectare of biomass, we can drive 67,000 kilometers. And that means in German situation, like the average car drives in Germany 12,300 kilometers. So that would be roughly 5.5 vehicles could drive with 100% biomethane. So we could calculate how many biomethane we need for all the vehicle, And we have to see in the future really the electromobility. And I believe that natural gas will be reserved for light duty vehicles and heavy duty vehicles. Because with electro batteries, to transport 40 tons of goods would be very difficult. But there will be many other solutions. So, like here, this example, Yameln, where we have our first biogas or a biomethane area, the people drive more because it's in a rural area in Germany. They drive 20,000 kilometers. And that would mean 3.4 vehicles per 1 hectare of maize. So here I have an abstract of the different biogas upgrading technologies. This is for adsorption. There's the pressure swing adsorption. Then we have absorption. There's the water scrubber. They're all scrubbers. But there's a water scrubber and there's a physical absorption and a chemical absorption. And there's one special here. I've seen this installation. In India is a low pressure water scrubber, and I have a picture I can show you later, and it's more maintenance friendly than our water scrubbers. Then we have the membrane technology, and then the cryogenic upgrading. So I would like to show just some samples, some flow charts, and then for some of them we have even filling stations. Here, like we said before, one of the most important is the removal of sulfur. So here we have now the swing adsorption technology. Before we're coming to the actual vessels or the columns in the container or in the PSA, here it's very important to get rid of the sulfur and of the water. And then we have different columns. Normally an installation will have 6, 7, 8 different columns, and they will increase the pressure in the column, which are filled with active coal. And they will have roughly a pressure of 4 to 7 bars. And when the active coal is full, it will be regenerated in steps. And for this, we have the vacuum pumps. And so then it goes to the next column, and there are many different types on the market for the technology. So the CO2 removal is done normally in the columns. So from the columns, from the vessels, the biogas or the biomethane will leave, and everything is done by controls. But this is only just a small flow diagram. To see the real installation, everything is installed in containers, and it's very, very compact. Like here, this is an installation for roughly 1,600 cubic meter of raw biogas. That means roughly 800 cubic meters of biomethane. And here we have the sulfur removal vessels. This one is a process gas storage, and this is for maintenance later on if there is any maintenance to be done, nitrogen. And this is an installation roughly for 2,000 cubic meter. But it's very compact, and the technique, so all the technique or all the things are manufactured in the factory, just delivered to the site and connected. And like we have in Germany, most of them are injected to the system. So here is one small PSA installation, and I just want to show a flow diagram here. Normally, the substrates are entering via a scale, entering, and then it's stored. And here, in this case, in Laupheim, which is in southern part of Germany, near Ulm, from 350 hectares, they have roughly 20,000 cubic meters of substrate stored there for the whole year. They're using 54 tons per day for loading the biogas digesters, and they have 2 digesters and 2 second digesters, and each one with 1,800 cubic meter and 1 storage tank liquid from 2,900 cubic meter. So from the biogas digester, like you see here, the flare, and it's very difficult to see the stirrer. The biogas goes with a temperature of roughly 45 degrees to the PSA here. But along the way, all the pipe work, all the stirrer, all the maintenance is done in a tunnel. And the tunnel is just underground, or it's under here. And so all the maintenance can be done in the tunnel. And then when the biogas is entering the PSE upgrading equipment, it's around 17 degrees Celsius. Here we have the off gas, like on each upgrading equipment we have off gas or methane slip. But here the off gas is used, which is roughly, it has only a content of 7% methane. But with 7% normally methane, you can't use any burner or can't use any engine. But there's special equipment like a microturbine, and then they're using this for heating the digester. So there is no big cogeneration plant here. It's only 100 kilowatt just for producing a little bit electricity, and some of the heat goes to the digesters. So the next biogas upgrading equipment, one of the most popular is the water scrubber with regeneration. So the raw biogas enters the first column, and like normally in a water scrubber, you don't have to do the H2S before the equipment. But here in this example, it's like the CO2 and H2S, the sulfur is discharged via these columns. So when it comes from the biogas plant, the pressure is roughly 5 millibar, 10 millibar, and then it's compressed up to, in stages, up to 4 to 7 bars. It will depend on the manufacturer. And then you see the first gas cooler, because that is one of the most important things, to cool the gas down and to get a certain pressure. And then from here it goes, the gas enters the scrubber, and you can see, and then here inside is filled with some plastic particles to increase the area for the solution to have it soluble. And then the gas goes out and goes to the biogas system. But it's all done it goes first through the flush tank, and from the flush tank it goes back to the system, and it's all counterclockwise when the water comes out. And the water will be going through here and up in the system. And then air is added to it. And then it's blown off. But you see here it's quite a lot of cooling done when you get the water back to the system. And it's with regeneration. So the H2O, the water, will be removed before it's entering the gas grid, or it's leaving the equipment. So this is a small plant in Sweden, in a water scrubber plant in Falköping, Sweden, which is used for a natural gas vehicle situation, and I will come to this a little bit later. It is on a sewage treatment plant, So they have two biogas digesters there. One is for the sewage, for the sludge, and one is for the waste, the biological waste from the 16,000 people from this village. And then they have the scrubber here, and the gas treatment here is like all these scrubbers, and inside here is the compressors and the cooling equipment. Here is the low pressure water scrubber from India, and this is particular, like I'm talking now about national gas vehicles, but this, even when you want to fill gas tanks, normal cylinders, you can do it with this system too, because they found out when they're using the biogas in the household for the kitchen or for heating or for light, and there's quite a lot of damage done. So they're using the low pressure water scrubber, and this is a kind of process storage tank, and it can be used for the different application, even for vehicles. But then you have to increase the pressure again. Here now an example of the physical absorption scrubber and using organic solvents. Here we have this example, Yameln, and there are 400 hectares of maize or of different energy crops, and they are farmers. They are in a certain society. They are delivering the biogas plant, and part of the biogas plant is going to the cogeneration plant, and then getting the heat for the heating system, and the other part is going to the electrical grid. And then, like you can see here now, like we had before the PSA in the water scrubber, we need only electricity and cooling, or the electricity we need for cooling and for the pressures. But here is the system is using some of the heat for the process of upgrading the biogas. So we have 400 cubic meters of biogas entering this upgrading equipment, the physical absorption scrubber, and 100 cubic meters is going, like you can see here, the carrot and the vehicle for national gas vehicles, and the other 300 cubic meter is going to the gas grid. Here we can see the physical absorption scrubber it's the same, in principle, the same like the water scrubber before. It's only like we have here a heating system in it for heating up the solvent or the solution of the organic solution. And all the, like the CO2, sulfur removal and water removal is done in the same kind of scrubbers. And like you can see here, we have cooling because it's done here, and here's the compressor. So what is very important in this system, you have to have a certain pressure and a certain temperature. And normally when the gas comes, it's very humid, so the condensate has to get out. But here with the physical absorber, everything is done at one stage. And like the new installation, most of this, like the sulfur removal and the water, is done before or outside the container or containers. So here in Yameln, the biomethane technology, it was this upgrading, the has a biogas upgrader, and it has to be done according to German standard, the G260 and 262. That is normally for all German biogas upgrading. And it has to be done to DIN. This is a German standard for natural gas for vehicle, because the sulfur content must be a little bit lower, like 5 parts per million. In this one, in the German standard for the upgrading, it's a little bit higher. So when the crude biogas is entering, it's roughly 50%, because it's using energy crops, and hydrogen sulfide is less than 5 parts per million, and the methane slip is 1%. and the water moisture will be absorbed. So the next one is getting more and more popular because it's using quite a lot of heat. It is a water scrubber again, water scrubber chemical absorption. You see from the layout it's roughly the same, but here we have the sulfur removal before, which is very important because we operate here the liquid, the solution, with a temperature of roughly 180 degrees Celsius. And there's not much energy used. I have a table later, you can see the difference. And though there are pressures and cooling system and heating systems. This is a typical example of one of the biggest amine scrubbers in Göteborg, Sweden, the installation. And you will see all the time these vertical pipes or columns coming out of the building or near to the building. Here we have now a technology, and it is now one of the biggest installation, membrane biogas upgrading, and which is getting popular. And we will see, because we have there's one installation, I will show you the filling station in Austria, but it's a very small one. But here it is roughly 250 norm cubic meters of biogas entering the cooling and drying plant. And here is the sulfur removal. So what they're trying to do is to have the cooling or the drying of the water, because we're getting roughly 100%, the humidity of the biogas is roughly 100%. And then we have here the compressor. It's entering here with 6.5 millibars. And then it's with the compressor is up to 6 bars. And then here in the active coal filter it goes through, and then it goes up to the first upgrading step, and then to the second one. And here particularly you can see quite well, like in every installation, this is one of the very important issues we have when it comes to biogas upgrading, is the methane slip. What we're doing with the methane slip. And there now technologies are developed, like you saw the micro turbine before, and there are many different technologies and spatial burners where you can use it and use the 7% of methane and use it for heating the fermenter. These are the membrane. Like you see, it's a small membrane, and there are thousands of small membranes, and the biogas is entering and separating the CO2 and the CH4. So this is the installation in Kisling, and here is, like you can see, the compressor, huge, but the membranes are very small. It's a small tube, and they have several tubes, and it's following. And here outside is the drying and the cooling, and these are the 1 and 2 separators, and this is the off-gas burner or a flexo burner, which is used then for the biogas plant for the temperature. So this is a relative new installation, a first big installation. There were small installation done in Austria, and I have some pictures from it. And like when maybe you can't see it too much on this picture, but when you see a PSA installation and an installation with a membrane, the pipe work, and it looks much simpler installation. So the membrane technology is really coming. And here we have the cryogenic installation, but I'm not too familiar with this. And I've given you some of the information here. And there are several steps. There are few installations done, and it is not very popular in Germany because we have everywhere gas pipeline. But in countries like Australia, America, and Sweden, where they don't have a system of gas pipelines, the liquid or the cryogenic biogas upgrading looks to me like a future possibility. But everywhere you read about it, it is very expensive. It's consuming quite a lot of energy, and I can't prove it. I haven't really any experience, but I have met these people, and I would like to see it a little bit further. And because this one would be particular, the liquefied biogas would be particular of interest for vehicles. And if you would go further in details, I think this looks like a very complicated installation, because we have minus degrees. It goes down to minus 161. And the energy is produced here with the gas from the installation and used for the TOR, that's the whole trace elements, H2S, water, siloxane comes out, and from here. And then it goes down in steps further down. It goes down up to minus 161 degrees. And the advantage is with 1 cubic meter of liquefied biogas, you can drive quite a long distance, and you can store it and you can transport it much easier. And here in this case, they're using even the liquefied CO2. And the CO2 is used for cooling and for greenhouses. So this is one of the first biogas filling station, liquefied biogas station in Sweden. And you can see it all the time on this huge tank. And it's now used only for heavy duty trucks. And but it's getting more popular. In Germany, nobody wants to talk about it, because even when you look on the German map, there is no terminal where you get liquefied gases from Qatar or Indonesia, because we have our industry who likes to install pipes. Okay, this is, sorry, the picture you can't see too much, and even I don't want to say too much, because that is particular the German injection system, the gas injection. It's a very complicated issue, and it's very difficult to explain. So now coming to the repeating nearly the energy demands for biogas upgrading equipment. Here in the first one, the pressure swing, I can go. It's the energy demand for biogas upgrading for 1,000 normal cubic meter biogas. It's roughly, to upgrade it, we need 240 kilowatt hours. 1,000 is roughly 6,000 kilowatt. And we need 240 kilowatt for the whole process, for cooling, for pumping, for pressure rising. And then here you see in the water scrubber, it's less, it's only 200 kilowatt. And here, with the chemical absorption, we have, or with the amine scrubber, we have quite a lot of heat. Remember, we need a temperature around 180 degrees, 160 degrees, and a little bit electricity. And here, for the physical absorber, we need heat and electricity. And for the membrane technology, it's less than 200 kilowatt. So there's no table yet for the cryogenic installation. Only here we have a table which gives us the different ideas and how the first step, how to compare the different installation. Like it starts with the investment cost, low, very low, high, very, and so on. But it's very difficult to say which is the best installation. You have to see if you have heat available, cheap heat available, then might be the amine scrubber the best solution. Because most of the time we don't use, in summer, we don't use the heat. And so maintenance costs are there, and the treatment costs if their chemicals are used. And like now, in the German law, the methane slip goes down from 1% to 0.5%. That makes it will make it even more expensive, or not so much more expensive, but we have to find different technologies. And here gives you the different of the load, how to control it, and here are the references of this installation. Like you can see here, the PSA and the water scrubber have roughly, in Germany, 20 installations. So we're talking about here, we have in Germany around 40, 50 installations, if you add them all together. That was up to last year, in 2009. And so we will see which technology will be advancing. So this is roughly a cost for the biogas upgrading equipment is roughly 1.2 to 1.5 million euro for 1,000 norm cubic meter biogas, raw biogas. And you see for 250 norm cubic meter, which is a quarter, but the cost is roughly 0.5 to 0.8 million euro. But that is because of all the injection, or of all the gas injection, all the controls is this price. If you would use it only for a vehicle, then the price would change because we don't need the injection. So specific operational cost is 7 to 13 euro per megawatt. So it's up to 0.7 to 1.3 cents per norm cubic meters. Then you can calculate it even for a kilowatt. And 13 to 17 cents for 250 norm cubic meter. Okay, just want to show some of the installation of the different ideas. Like in Germany, like you saw, we have all this big piping system, or we have 440,000 kilometers of pipeline. So a filling station is just connected near to a gas pipeline. And then we need the compressor. But in Sweden, like you have seen the picture before, is like here's a town of 16,000 Falköping, of 16,000 inhabitants. So there's a sewage treatment plant. All the sludges goes to a biogas digester. They have one biogas digester for the sludge and one biogas digester for the solid waste. And then they're using the water scrubber, treating it to their standard. I don't know, it's roughly the same like the German standard, and they have only different letters in front. And then they're transporting the gas over a distance of 4 or 5 kilometers to a filling station. And in this filling station, they compress the gas and they're using it directly there. And then they have a system, like you can see the truck here on top. They're discharging the gas into on trucks or on containers and bringing it to the next filling station because there is no gas grid. And this is what they call mother and daughter installation. So here is one of the installations. This is the mother station here with the compressor, and here the dispenser, and then they're transporting it to the different daughter. And it can be in a radius 50 to 100 kilometers. And in Sweden, they sell their gas by cubic meters or liters. And so you can see here the truck is going to the station, just discharging it, and then they're connecting it and for the other filling. And the prices in Sweden for the natural gas is nearly the same like the normal filling. Not like in Germany, we have many or half the cost. And here's even a bus can use it. Here is another small, like I have given you one of these leaflets from Finland, is a small biomethane filling station on a farm. And these people from Metana who have done this installation, they're coming even, or some of them coming next week to the study tour. And but they're coming here to see. They don't want to sell their equipment to Germany because Germany is for them too complicated. because of all this injection and TÜV and whatever. So here they have a biogas in a farming community very far from the next town, 40, 50 kilometers. But luckily, near to the farm, there is a sweet company. So they're taking all the bio waste from the sweet company and producing, that was last year, for 15 vehicles. I think they have now more vehicles. And the water scrubber is only for 50 cubic meter. And this is the whole 50 cubic meter scrubber. In Germany, nobody believes it, that you can get equipment so small. But it can be done if the industry is not behind it. If they're like the farmers and the university from Jyväskylä, they're doing this. And it's very promising. And the price is roughly 300,000 euro. Here we're coming back to the Jameln biogas plant, where we have biogas upgrading equipment here, which is 900 kilometers from the compressor or from the filling station, and then from the filling station it goes to the dispenser and then vehicles. 900 meters, yeah, 900 meters. So the example in Jameln, the biogas production, including energy crops in biogas plant, is roughly 6 cents per kilowatt hour. If you would have waste or a manure or a pure thing, the cost could come down. Because our substrate, maize or whatever, can be very expensive or can fluctuate. And so 6 cents. And then the biomethane treatment process is roughly 1.82 cents per kilowatt. And so the total cost without the filling station is 8.2%. And these farmers, they're still investing money in it. It is not up to now coming to the point, because when you go to the German filling station, the price for natural gas per kilowatt hour is only 5.5 cents. But they have done it for other reasons. Because near to their farm or the Jameln, there should be the storage place for all our nuclear waste. And they're demonstrating all the time, they say, but we want to do something different. We don't need this nuclear power. We would like to have renewable energy. And so the farmers even pay for it. Okay, like for this station, it's like in Germany, a filling station has 8,500 kilograms per month. But in Jameln, it's double the amount because the people are behind and they have many more vehicles. So I just want to show you the sale. That was even one of the first biogas upgrading plants in Germany. It went up to 2009, up to 15,000. And I think they are now over 22,000 kilograms per month. Cost driving a vehicle, 20,000 kilometers when you use super petrol is 2,500, diesel is 1,870, LPG is 1,380, and using Biogas or Sungas is 1,050 or 80 euro. So there is a cost saving of nearly 50%. And like in Germany, we are selling our CNG in kilograms, not in kilowatts. So comparison to a liter petrol, our gas is only 61 cents compared to 1.4 euro. So there's quite a lot saving, and the government is promising not to put too much taxes on it. And here the emission when using, like in Jameln, we have 100% biomethane. So the CO2 savings for the vehicle is for 20,000 kilometers would be quite a lot. It is like you can see, it is neutral here. And when using super, we have 4.4 tons and 3.4 tons for diesel, LPG 3.8. So the saving would be roughly 4.4 tons per one vehicle. And if you have more than 200 vehicles or 2,000, you can multiply this and you find the CO2 savings. Here it is a small farming installation. It seems like the farmers have done this small upgrading plant, membrane, like you can see, like the big one, is like the compressor, and here you have the membranes. And they're using even it for tractors and for the whole vehicles. And they have a dual fuel engine here, diesel and biomethane. So I just want to remember, and I think it's a very important issue, when we're talking about vehicles, we have to talk about accidents. We have to talk about the air pollution. And here you see, like, in every year, more than 250,000 people die because of car accident. Over 10 million people are injured. And here, the motors, the engines, contributing to the cocktail of entering the Londoners' lungs. And I think they have closed down partly the London city for this reason. And so introducing more garbage trucks and more buses with biomethane would help quite a lot the health issue. So now the advantages when using CNG and biomethane as a fuel is CO2 reduction 25 to 85%. And if you use biomethane, it depends on the mixture of the substrates you're using. It can be much, much higher than 100%. NOx reduction is up to 95%. No soot particles, no smoke, no filling emission, like when you fill the gas to your natural gas vehicle, you don't smell anything. And the CNG and the biomethane can be direct supplied to the gas grid. Lower fuel cost, independent of overseas supply. I think that's a very important issue too, independent. The disadvantages, not enough filling station. This is what people very often complain, or they have to wait more than 4 minutes for filling their vehicle. And the taxation here in Europe is not really considering CO2 reduction in vehicles. They're giving guidelines, but I think that will come if you have the benefit of the CO2 reduction. And the public is not aware. Like in Germany, it's very seldom that people know about it. Even when you go to Volkswagen dealer or a BMW dealer, they don't know anything about it. They're not trained in it. Even in our training schools. And that is part of our project, that we're trying to make more public awareness. Okay, and for some relevant web pages, it's certainly our web page here. That's the International Association. Biogas Max, they have done quite a lot in this. And GasHighWay Net, that's a part of our project. Like we're only 1.5 years in the process. But here is a very interesting web page, the Biogas partner from Germany. And it's in German and English. And if you look at the downloading section of this internet page, you can find biogas upgrading technologies, development and innovation. There is in English from the International Energy Association, and it's a very good brochure. But there are many other German documents. You can have a look at it. And Madagascar, it's another European Union project which has finished, but there's some very informative information in it. So I would like to say thank you for your attention and for your questions.